the hydrocarbons, alkenes, alkynes. Then we studied about the halogen compounds. Okay, so some things are usually common. So today we are going to learn about the hydroxy compounds. So in this, first we'll read about the homologous series. This you have already studied in your lower levels, homologous series. For example, first of all, let us see what are alcohols. So alcohols, they are organic molecules. They contain hydroxyl group, OH. It is known as your hydroxyl group. So here one hydroxyl group substituted into an alkane molecule and the general formula will become CnH2n plus 1 OH. So for alkane, if we see the general formula is CnH2n plus 2. But if we write for alcohol, then for alcohol it is CnH2n plus 1. That means one H is substituted by a OH group. So this is the general formula. And how to write them? So we will add all, okay, after the name of the alkane stem. For example, CH3OH, it is called methanol. Similarly, if I write CH2, CH3, CH2OH, so there are two carbon atoms, we write ethanol. Similarly, if I write CH3, CH2, CH2OH, then it will become propanol. Okay, the last E of the alkane is replaced by OL as a prefix. Clear? Okay, so make a heading, hydroxy compound, and write it down.
I'm done.
Okay. So this is your homologous series. Like methanol is the first member, then ethanol, then propanol, then butanol, and so on. Okay, so homologous series means you are adding the CH2 group. Okay, there's a difference of CH2 group. So here you can see propanol, propane to all, and 2-methyl propane to all. I hope you know IPSC name 1, 2, 3. So it is 2-methyl. Okay, sorry, 1, 2, 3. Yes. So it is 2-methyl propane to all. At second position you have methyl, and at the second position you have alcoholic group. Note that the numbering to show the position of the OH group in an alcohol starts from the end of the molecule, that gives the smaller number. Okay. So here the counting will start from 1, 2, 3, because first rule is that you have to see the longest carbon chain. You cannot start like 1 and 2 because this is not longest chain. So first of all you have to see the longest chain. Then you have to remember about primary alcohol, secondary and tertiary alcohol. Okay. So where OH group, the carbon which is attached to OH group, okay, it is connected to one alkyl group, so it is 1 degree. The carbon which is attached to OH group is connected to 2 alkyl groups, it is 2 degree. And the carbon which is attached to OH group, it is connected to 3 methyl groups, 3 carbon, it is called as 3 degree. Okay, write it down. Okay, so Shama also has joined. Can you hear me?
Yes.
Okay, so today we have started a new chapter, hydroxy compounds, in which I have just told about the homologous series of alcohols. So if you want, you can take a screenshot of this, where one OH group of the alkane is substituted with the OH group. Second thing is that about the 1 degree, 2 degree and 3 degree alcohols. So this is the same as we have discussed in the alkyl halides, that if it is connected to one carbon atom, it is 1 degree. If carbon atom which is connected to OH group is connected to 2 carbon atoms, it is 2 degree. And if the carbon atom which is connected to OH is again connected to 3 other carbon atoms, it is 3 degree alcohols. Write it down.
I'm done. I'm done.
Okay, so here propanol, it is classified as primary alcohol because the carbon atom bonded to the OH group, it is attached to one carbon atom, alkyl group. Propane-2-ol, it is called a secondary alcohol because the carbon atom bonded to OH group, it is attached to 2 other carbon atoms, alkyl groups. But if you have 3 alkyl groups, alkyl may be anything, okay, methyl group, ethyl group, propyl group, then it is called as tertiary alcohol. So 2-methyl propane-2-ol, it is your example of tertiary alcohol. How it is made? Propane, at 2 position you have methyl, and at second position you have alcohol. So this carbon atom, it is connected to 1, 2 and 3 carbon atoms again. So it is called a tertiary alcohol.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
I'm done. I'm also done.
So when an alkene is oxidized to form a diol, ethane 1,2-diol, its structural formula is CH2CH2OH. Diol means two alcoholic groups. Okay, what is the formula of ethane diol? CH2CH2 and OH group. So this is the structural formula. Both the hydroxy groups are bonded to the CH2 group, so both are classified as primary alcohol. On the other hand, diols such as propane 1,2-diol is made like this: 1, 2, 3 carbon atom. Okay, so in propane 1,2-diol, at first position you have OH group, and at the second position you have OH group. So you have to just fill the valencies of carbon. So here, this carbon which is marked as first, okay, it is a primary alcohol because it is connected to only one carbon atom. But this carbon which is marked as second, it is connected to two carbon atoms. So it is a 2-degree alcohol. Okay, so in one compound also we can have a primary and secondary alcohol both. Done?
Yes.
The next is the properties of alcohol. So they have higher boiling points as expected as compared to the alkanes. Okay, with the similar relative molecular masses. Why they have higher boiling point? Because of hydrogen bonding. Even methanol, the alcohol with the lowest molecular mass, methanol is just CH3OH, lowest molecular mass. So it is a liquid at room temperature. So this occurs because of hydrogen bonding between alcohol molecules. Hydrogen bonding means hydrogen is connected to the more electronegative atom, in this case oxygen. Hydrogen bonding also explains why the smaller alcohol molecules, they are so mixable in water. So they are miscible in water. Why? Because of the hydrogen bonding interaction. Even smaller alcohol molecules, they mix and dissolve in water very well. So write down the problem.
I'm done.
Okay, now let us see let us compare the acidity of alcohols and water. Which is more acidic, alcohol, ROH, or water, H2? So let us see. So when you dissolve in water, ethanol molecules, they do not dissociate, that means split up to any greater extent, although there is a very small degree of dissociation. Okay, so this is, you can see the arrow, it is going to the backward direction also. That means it is not completely dissociated into its ion. The position of equilibrium lies well over to the left, favoring the undissociated C2H5OH, that means ethanol molecules. Even compared to the dissociation of water molecules, water also it is not completely dissociated into H plus and OH minus ions, but the concentration of the concentration of H plus ions is much lower. Okay, so we can say that ethanol is a weaker acid than water. Its molecules are less likely to dissociate and form H plus ions because of electron donating alkyl group, okay, bonded to the negatively charged oxygen atom in the ethoxide ion. The positive inductive effects of the ethyl group, the positive inductive effect means they are donating electrons to the O negative ion. It has the effect of concentrating more negative charge on this oxygen atom, which is already negative charge. And ethyl group is donating electrons to it. So the ethoxide ion more readily accepts an hydrogen ion than the hydroxide ions from the dissociation of water. The hydroxide ion only has a hydrogen atom bonded to its negatively charged oxygen and no alkyl group. Okay, so I'll explain this to you more clearly. First, write down this. Write down the dissociation.
I'm done.
Okay. So I hope now you understand that why if someone asks you that which is more acidic, water is more acidic or alcohol is more acidic. So which is more acidic? Water is more acidic. Okay, why? The reason is that water is H2O and alcohol is ROH. So to determine that which one is more acidic, you just lose the acidic proton. So after losing the acidic proton, it becomes OH minus, and after losing the acidic proton here, it becomes RO minus. So we have to see the stability of these ions, OH minus ions and RO minus ions. So R is what? R is your alkyl group, which is electron donating group. Okay. O have O means oxygen have negative charge on it. Okay, so alkyl group is donating electrons to it, so it is destabilizing it. It is destabilizing it. While in the OH minus ion, it have only hydrogen. Oxygen is attached to only hydrogen, which is not donating electrons to it. Okay, so if we see the stability, then this hydroxide ion, it is more stable as compared to this alkoxide ion. This is known as alkoxide ion. So what does it do? It readily accepts a proton and it becomes ROH. And the tendency to accept a proton is acid or base? Basic. Tendency to accept a proton is basic. Okay, that's why it behaves as a base. While if we talk about the acidity, then H2O is more acidic as compared to ROH because of the stability of their conjugate bases. Conjugate bases means when we lose the acidic hydrogen, we have OH minus ions and RO minus ions. So we see the stability of these two ions. Is it clear?
Yes.
Yes.
Write down your, take a screenshot of your homework question. Explain how hydrogen bonds arise between ethanol and water molecules. Explain why ethanol mixes. So all these questions I've already discussed. This question is from the physical properties of alcohols and this is from the organic chemistry. Okay, so take a screenshot of this.